Today we're going to be studying proportionality, and this is similar to some things we've done before. It may be like the same exact thing that we've done before, at least this problem here. And proportions are set up so that this fraction essentially equals that fraction, even though the numbers may be different. Now, the way we equate these two fractions is we cross multiply. And so we're going to multiply 20 times 9. Then we're going to cross multiply the opposite numbers, 6 times x. And in proportionality, the cross multiplications will equal each other. They're called the product of the means times the product of the extremes. And I won't even bother with you which one are the means and which one are the extremes. It doesn't really matter because they're both equal to each other. But we multiplied 20 times 9, that's 180, and we multiplied 6 times x, and that's 6x, and they equal each other. So if we want to find out what x is equal to, we're going to divide both sides by 6. And that will isolate our x, and 180 divided by 6 is 30. And as you can see, 20 over 6 is proportional to 30 over 9. And now let's try that with a binomial. And we're going to solve this the same way by cross multiplication. And if you look at this, you might be thinking, I could see other ways to solve this. And that's true. And that's fine. You can use other ways if you want. I can think of at least 3 ways to solve this. But we're going to learn today, and I think it's really important for proportionality. It's also the easiest. In my mind, it's the easiest. So x plus 3 times 5. Yeah, don't forget that x plus 3 is a binomial, and so we're going to multiply the 5, not just times the x or just times the 3. We're going to multiply it by both terms. And so that's going to equal 8. 2 times 4 is 8. And so let's multiply out our binomial. Get that 15 on the other side. Bring that down. 5x equals negative 7. Divide both sides by 5. And that isolates that x. And x equals negative 7/5. Okay, so we know how to do our proportionalities now. Why don't we do a word problem? A 6-foot-tall man casts a shadow that is 3.5 feet long. If the shadow of a flagpole is 8 feet long, how tall is the flagpole? Okay, this is how we're going to set that up. And since we're talking about proportionality, to do a proper proportionality, you need to be talking about the same thing. So in our first fraction, we're going to talk about the shadow of the man and the height of the man. The other fraction is going to be the shadow of the flagpole and the height of the flagpole. It's very important that you see how I set this up, because everything falls into place if you do it this way. Over here, this fraction is talking about the man. Over here, this fraction is talking about the flagpole. Now, the numerator of both is the shadow, and the denominator of both is the actual height. Now, you could have done this upside down, and that's fine. You'd get the same answer. But now that we know how to set this up, let's just start inserting numbers. The shadow of the man was 3.5 feet. His actual height is 6 feet. So we have our man set up, and now let's set up our flagpole. The shadow of our flagpole is 8 feet, and how tall is the actual height of the flagpole? Well, that's the question. And it didn't give us that information, so put an X there. And there you go. We have a real simple problem now. I am going to really encourage you. Now, the book doesn't do this, and as a matter of fact, I've never seen any book that does this. Putting these initials here like this. And just, it's going to avoid a lot of confusion. And as you're reading word problems, you know, at your age, word problems are really difficult and you have trouble. How do I set this up and how do I set that up? Well, if you just look at it as proportionality, got the man on this side, we got the flagpole on this side. We got the shadow on top, and we got the actual height on the bottom. Now, by the way, you can put the actual height on the top and the shadow on the bottom. Doesn't matter. As long as you're going from shadow to shadow and actual height to actual height. Okay? Make sure that you're consistent with that. And now, 3.5 times x is 3.5x. And 6 times 8 is 48. Divide both sides by 3.5. And that isolates that x. And 48 divided by 3.5 is 13.71. Now, the book says 13.7. Normally, in algebra, if they don't ask you how far to carry out a decimal position, it's usually 2. It's out to the hundredths place. So he put 13.7. So for our purposes, I really am going to require that you do it to the hundredths place. Now, a couple of things that are going on here is you're mixing decimals and fractions, and you really shouldn't do that. And if we hadn't mixed the decimal there, it would be 13.5, which would be a fraction over a fraction and that whole mess. So you could solve it that way. You probably have a calculator that turns this into a fraction, and that's probably what you should do. The rule in math, I was going to say algebra, but really in all math, is if they give you a problem in a fraction, then you give them an answer in a fraction. If they give you a problem with a decimal, then you give them an answer with a decimal. And you know, actually, the question did say 3.5. It didn't say 3.5. I said 3.5 just because it means the same thing. But you could do this. It's probably just as correct as anything else. The fraction is not what they gave us. The fraction is what we used to obtain an answer. So this is a little mixed up. I think whatever you did in this problem, I would consider correct. And so our answer is 13.71. No, it's not. Read the question again. It's 13.71 feet. Now, if they ask you a question in feet or inches or whatever they ask you for, you better give them an answer in the same measurement. If they're giving you miles per hour, don't be giving them kilometers per second. And now Mr. Wallace and I like to work the same way. We like to work without all the feet and the miles per whatever. Most books, they kind of have you working with those measurements, and I think it just gets in the way. We talked about that earlier in the year. I think it gets in the way. But remember, in the final analysis, you have to bring those measurements back in there. So it's 13.71 feet. Okay? I mean, if you're buying a flag for your flagpole and you're going into a flag store, by the way, I've done this, and they ask you, well, how tall is your flagpole? And you go, 13.71. 13.71 what? Oh, just 13.71. I don't think so. You better be able to tell them it's 13.71 feet. And there you go. Make sure you do your homework.